Hi guys, welcome back to this video. So today we'll explore functional programming, a subject that comes often in learning any programming language. So functional programming is a way of programming that revolves around, of course, using functions. So instead of using variables to store information or to work with the information, we actually use functional programming. And that's because it has benefits. One of the benefits of functional programming is abstraction. So we don't need to detail each step, and that leaves room for less errors in our code and less bugs in our code. And second is that for me, it's more professional. At least when you use functional programming, you are demonstrating that you know your craft, right? So I'm going to show you, it's actually not that difficult, even though it can be challenging at first to grasp its concepts. So the three pillars of functional programming are usually, so map, we have the select or filter, which is the select, and we have the reduce in Ruby, which is inject. That's the same name. And for map, we have collect. So every time we see collect, it means the map. Same for filter or reduce. So the first one is the map. And now that we will use this mostly for arrays, right, or for collections. And we'll work with arrays to show you that even though we can use it in hash maps or objects, right, in Ruby. Let's just make it simple. We'll work with an array, and let's say we have series array, and we have Paris, we have New York, we have uh, Tokyo, right? So Tokyo, and we want to say that we went to all these cities. Okay, so with the map is going to look through the array, and for whatever item in the array, it will return a new item. Okay, so I can say here cities that map, and we will return here. So the map always returns a new array. Uh, so we will do transformation here. So for each item, we'll give it our block here. So we can say city, and we'll simply return a string. So I went to, and the city name. Okay, and then let's store it here in, okay, say new or result. And if we print the result, we can see that. So if we say Ruby app.rb, which is that for each item we returned, it transformed with this. Okay, so I went to Paris, I went to New York, and I went to Tokyo. Same for, let's say here, numbers. So if you want to say we have numbers like this, and we want to return, let's say, the double for each number, we can do the same with the map. So we say result still equals some numbers that map, and for each number, so we'll have the number doubled. Okay, so this is the number doubled, and if we print the result, so for each number we are having it doubled like this. So the map is useful in these situations. If you wanted to transform an array into something else, and it always returns a new array, but it won't change the numbers. So if you print the numbers. Let's see what we have. So we still have our original number. So that's another benefit of functional programming, is that we don't change our initial array because we might use it in the future. We might need it somewhere else. And same for, so as I said, collect is the same as map. So I can use here as well collect, and I would have the same. Okay. So whenever you see collect, just know that it's the map as well. So it's just interchangeable names. Next is the filter. So the filter is a way to filter items that we want out of the array. Let's say here we have odd numbers and even numbers. Let's add more items. And we just want to filter out odd numbers out of this array. We can have here, so odd numbers. We'll use the filter by saying numbers. So numbers. So select and filter are the same. We can say filter. Let's give it our block. So for each number, we'll only select numbers that are odd. So we can say odd like this. Okay. And we can print. So print odd numbers. I have a typo here. Let's correct it. All right. And let's comment out this. Clear. Right. And then you see that it selected only the odd numbers out of this array. Same for cities, or we can have words here. Okay, say apple, pear, so bananas, okay, tomatoes, and so on. Guava, something like this. And we want to just filter out words that have a length less than 5 letters. We can do the same for short words. We say words, filter. We only select the word that lengths that are, let's say, 4, and we can print out short words. Okay, we don't have any word, so let's say 6. So we have apple, pear, and guava. Right, so this is the filter. We could say here select, okay, and would have the same result. So filter is select. Next is the more challenging one, and that's reduce. So reduce is going to take a collection or a hash and then reduce it to one number. So we will take everything, and then we'll, at the end of the reduce, we just have one item, can be one array, one number, one hash map, one string. So we can do things like addition, multiplication. Let's say we want to know the sum of these numbers. We can use the reduce, right? We could use here a loop. Okay, store the result in an array. Let's say here reduce, but we'll first see how could we do the sum of numbers without the reduce. So we'll have here sum 0. So we'll use the each to iterate through the array by saying numbers dot each, and for each number, right? So let's say for each number, and we'll have our end. Yeah, so for each number we'll say sum plus equal. Okay, we'll add the number, and at the end we'll have our sum So let's use interpolation, say sum. It's actually the other way around. So here, okay, we have 50. Okay, so 50 is the sum of our numbers, but we see that we are doing it by creating here an array and looping through the array and adding the sum, the item to the sum. But we can do it with a reduce. So with the reduce, we can just say sum equals, let's comment this out. We say numbers that reduce. Let's give it a block. So the sum, which is initial value, is by default 0. It gives it initially 0. We can say total instead of sum. So within the loop, it starts with 0 by default. Okay, and then we have our current number. So the current number is going to be first 2 and then 4 and then 8. Every time it goes to the next item in our loop, this num changes, and this is the initial total. So what do? We just return total. We add the sum. Okay, so that's how we do it. And we can print, so reduce sum, and we'll have our sum. Okay, yeah, it's num. So num, and we'll have the sum, which is still 50. So let's even replace this with inject. So let's clear this out, and we still have the sum, which is 50. Okay, let's say p outputs, comment this out. So we have the 50. So that's an overview of the map, filter, and reduce. In functional programming, you see that it's quite simple most of the time, so it doesn't take a lot of multiple lines of code, and it's straightforward.